Okay, now this is the beginning of 5.2, which would be the second page of my notes. I'm gonna kind of walk you through it and see what happens from there. So we talked a little bit about simple interest in the previous video. This is simple interest. So we'll kind of see how this one works here. Simple interest was when you compound them or you charge interest one time. Um, Compound interest is when you're charged multiple times on top of the interest you already paid. It's calculated over and over. So the formula for compound interest is future value equals p times parentheses 1 plus I, all that raised to the nth power. It's exponential. N is what they call the number of total compounds. So they charge you money on top of money on top of money on top. So if you're late a month, they charge you money for that. If you're late a second month, they charge you on top of the first month's late. So they compound it. So N is how many total times they're going to compound throughout the money that you borrow, throughout the time you borrow the money. N is understood to be M times T, where M is the number of compoundings per year and T is the number of years. So M is understood to be throughout a year. So if they say annually, M is 1, semi, M is 2, quarter, M is 4. Again, 4 quarters in a year, 2 halves in a year, 1 whole in a year. Monthly, M is 12, 12 months in a year. Daily, assuming it's non-leap year, 365 days in a year. And then weekly, M is 52, 52 weeks in a year. Where essentially T is a number of years, so if you multiply M times T, you get N, and so that's where this formula comes from. I, in this formula, is not the simple interest from the previous one. It is how much you pay for a compounded period. So if they charge you quarterly, it's how much you pay interest every 3 months. So they divide the total interest rate, the annual interest rate, by the number of times per year. That's going to tell you how much interest in that particular period. I'm going to pause it for 1 second. Excuse me. Okay, sorry, I have to cough a little bit here, but so the formula becomes future value is present value times 1 plus r over m to raised to the m times t power. This is the number of compound interest per year, or per year over the number of years that you're going to get compounded. This one is called continuous compounding. Now this one theoretically is every second of every minute of every day of every week, all the way through the years. Like it's every single second. So again, E in your calculator is what they call Euler's number, 2.178 ... This is Euler's number. Okay. Now, in case you're not familiar, hopefully you have a scientific calculator has a natural log button right here. On top, I'm sorry, you can't really see there, E, that will give you a natural log on the calculator, but you don't want that, so I'm going to clear it, and I'm going to actually put second, the same color as the E button, E. I'm going to press the first power because if there is no power, it means E to the first. So that's where you get this built-in function the calculator has. So that's Euler's number. It's a built-in function. You get it by pressing inverse or second and then natural log, ln. Okay? Continuing on. Here's a few problems that talk about interest. I'm going to walk you through it and I'm going to give you some more examples of something else. So let me see if I can do this here. I don't know if I can get this, but give me a second. If I could do this kind of off to the side here a little bit. I'm asking for you to calculate the interest, the compound interest. So number one, it has $10,000, which is essentially your principal, compounded monthly. So M is 12 number of times per year. There are 12 months in a year. T would be the 2 years, and your interest rate would be 5%. Excuse me, I'm reading the wrong problem here. 6.4%. Again, moving the decimal 2 places left, you get 0.064. That is your interest rate. So you have your time and your M and your T. So I can come over here to this formula, but because the I is really R over M, the N is really M times T, I'm going to refer to this formula. Makes it a little easier rather than going to this one, because I'm still going to have to put values for this one. So I'm going to use the formula. Future value is, put it here, principal times 1 plus r over m to the m times t power. So in our case, you have 10,000, which is essentially your present value, then 1 plus your interest rate, 0.0624, divided by the number of times per year, 12, raised to the m times t power, 12 times 2 power. Again, I'm going to put a little x so it doesn't confuse you. So this is going to be the formula. So when I do this, I'm going to see if I can zoom in here a little bit so you can see the calculation a little bit better here. So let's say 10,000 times parentheses 1 plus 0.064 divided by 12, close parentheses. Now, everybody has this is the exponent. So everybody has a different button. I have the little house top there, little carrot top. Parentheses, 12 times 2, close parentheses. So this gives you a total of $11,361.66. Again, 2 decimal places. And so essentially move this over. Essentially, that's all it's asking for here. Just run formulas. Hopefully it's not so bad. And now let's see number 2 here. Let me kind of zoom out a little bit as much as I can. And so number 2 says 20,000 compounded quarterly for 10 years at 5%. So the present value is 20,000. Quarterly. Quarterly means 4 times a year. Again, it becomes 3 months, every 3 months essentially. So there's 4 times a year. So quarterly means 4 for M. T is the number of years. And the interest rate is 5% of the given problem. But again, you want 2 decimal places to the left. So that's 0.05. You have your time, your M, and your present value. So I'm going to go to the same formula. The future value would be present value times 1 plus 0.05, your R, divided by your M. Again, that division there is your I. So raised to the M times T power, which is essentially your N. Your M is 4. Your T is 10. So I'm going to hopefully put that into the calculator. And I hope that you can see this okay. Let's see here. 20,000 times parentheses 1 plus 0.05 divided by 4, close parentheses, raised to the parentheses 4 times 10, close parentheses. So $32,872.39. And that's pretty much how you do this. I'll do another one here. I'm gonna finish these 5. You probably might not need all 5, but hopefully the video won't last too long here. 75,000 compounded weekly for 8 months at 0.5%. So again, the present value is 75,000 weekly. That means that there are essentially, weekly. The number of compounds will be 52 because essentially there are 52 weeks in a year. The time is 8 months, but now this is 8 out of 12. So I'm going to put it as 2/3. Now the reason I don't put it as a decimal because it's going to be 0.667, it's going to be a long decimal. So I'm going to leave it in this case in the fraction form. Yeah, that's just preference. If you use a decimal, that's fine, but it's going to be the approximation is going to be off. And I think the computer understands very close. Like you have to be really close. So leave it as a fraction for here. Move the decimal 2 places. This is 0.005. And so using the formula, the future value would be 75,000 times parentheses 1 plus R, which is 0.005 divided by M 52 raised to the M 52 times T power. T would be 2/3, right? So having that, how this works. I'm going to hold the calculator so you can see this a little better at my screen. 75,000 times parentheses. And this is a little harder than I thought it would be. 1 plus 0.005 divided by 52, close parentheses, raised to the parentheses, 52 times 2 divided by 3, close parentheses. And so you get 75,000, what looks like $250. This is kind of not that much interest because they're charging you less than 0.5%. Typically, this is what banks do to you. If you're lucky, you get like 0.5%. So you put money there 8 months, and you only get $200 interest, as opposed to putting your money there for 10 years and getting like 12,000 interest. So you put in 75,000, you expect to get a lot of interest, but they don't. This is mostly what you have to pay back. So just want to throw it out there. And now number 4, it talks about continuous. That is your second formula. So the future value is P times e to the RT. So in this one, the principal or the present value is 2,000. The interest rate is 3%, which would be 0.03, and your time would be 6 years. So the future value would be 2,000 times e raised to the parentheses r times t. So 0.03 times 6, and then we'll close. We'll put approximate. And so I don't know if you can see this or not, but I'm going to put 2,000. Now, oh, sorry, you can see that. 2,000 times second ln, and that's going to give me the e value. But now it's going to be 0.03 times 6. So that's $2,394.43. And that's what we're looking at here. That's the interest there. Or that's actually going to be how much money after the interest. So it's about $394 of interest. Number 5, $800 compounded monthly. So in this case, again, $800 is your principal monthly. You know what? To make this more the same, I probably should put this continuous as well. Let me change this to continuous. Continuously. Just to make my point here. $800, the interest rate is 8.1%, which when you move the decimal to the left 2 places, 0.081. The time is 20 years. And so in this case, the future value is present value times e raised to the 0.081 times t, which is 20. And so this is essentially what I'm going to kind of plug in there. So 800 times second ln to get the e value, 0.081 times 20. So you're talking about future value about $4,042.47, plus or minus. Okay, so that's how that works. Then if I may here, that should put us about halfway through the section. So let me talk to you briefly here about, or a little bit about, what is called, let's see, give me a second here, I'm gonna get this. Okay, you can see that. Okay, I'm gonna go to the bottom of the paper here. Present value is future value times 1 plus I over n, 1 plus I raised to the nth. But because I is r over m and n is m times t, I'm going to use this formula. So I have these 2 problems and then these 2 formulas. So let's see how that works. Okay, so let me back this up. See if I can turn this a little bit sideways. Hope not to mess you up too much here, but so I can get both of them in here. Both problems in here a little bit, if I may. Now, it's kind of far away here, but Keith paid back $25,000 total after 5 years. Okay? At an interest rate of 8% compounded monthly. What was the approximate amount that he borrowed? So to figure out the present value, you need future value. So this is how much he paid back at the end. So that's your future value. So in that problem, number one, the future value is 25,000. After 5 years, that means that t is 5. Interest rate of 8%, which means 0.08 as you move the decimal 2 places to the left. And then your this special word here, this special phrase, monthly. M would be 12. So you have the pieces. So now let's look at the formula. The principal here, if I may, let me put this over this one here. It's future value divided by 1 plus r over m to the mt power. And I guess I didn't really explain that earlier. The reason the reason that comes about is because over here, all they do is divide by all this parentheses stuff and solve for p. And that's where you get this formula. I should have explained that sooner. Sorry about that. So let's see if we can compute this at a reasonable rate here. So this would be 25,000 divided by parentheses 1 plus interest rate 0.08 divided by 12 raised to the 12 times 5 power. Now, I don't know if we can see that too well or not, but that's essentially, that's a 5 there. So I hope this comes out okay. See, I have to aim this just right here so you can see that. So let's see here. I'm going to put 25,000. Now, you gotta be careful here because you're going to divide by this whole entity raised to a power. So I'm going to put a second parenthesis around the whole thing. So I'm going to actually put 2 parentheses. One for the whole thing around, all this on the bottom. And then the second one is this one. So 1 plus 0.08 divided by 12. I'm going to close that parenthesis in here. And then I have to raise it to a power. So I'm going to do my little casita, my little exponential button. And another parenthesis to put this in there. 12 times 5. I'm going to close this parenthesis, but I'm going to close a second imaginary parenthesis. And it equals. If it's easier for you, if you like, I'll put a second parenthesis in red around everything so you can know that's what I did with the calculator. So the total is about $16,780.26. Roughly, that's essentially how this works. And I'll do one more here with this. We'll talk about, I know it's kind of far away here, but let's see if you can see this okay. Again, I'm going to print this out so you can have it with you. But Nancy is trying to make enough to afford a $10,000 payment in 2 years from now. If she invests into an account giving 6.8% interest compounded quarterly, how much does she need to invest? So she wants to afford a $10,000 payment in the future. So that's your future value is 10,000, and your T is 2. So your future value is 10,000. Your T is 2. Then she wants to invest in the interest, give an interest rate of 6.8%, which again, the decimal moves 2 places to the left, 0.068. And then she wants to compound it quarterly, so M is 4. So like the previous problem, you have the values that you need. It becomes a matter of plugging it in. Or let me just, I want you to be able to see this okay. So if you look at all of this, the present value would be the future value divided by parentheses 1 plus 0.068, which is the R, divided by M raised to the M times T power. And then I'll put the extra parentheses here in red so you can see what I did there. that being said, let's see if I can kind of turn this around. This is tough to get the angle here. Okay, so 10,000 divided by double parentheses, 1 plus 0.068 divided by 4 first parentheses, raised to open parentheses, 4 times 2 close parentheses, close second parentheses, and you get about 87.38. 87.38 and about 41 cents. So it kind of makes sense if you want your investment to jump to 10,000 in a matter of 2 years, compounded 4 times a year, you need to put about $8,700 in there, essentially. So that takes care of that. So now let's talk a little bit about the last part of this. If I may here. This off a little bit. The last part is what we call effective. I'm getting used to this camera thing here. Effective rate, which is R sub capital E, R sub E, or what's called the APY, annual percent yield. The formula is the formula. See, the other one was P times all of this mess. Okay? So what they did is they took the P times all of this, which would be the future value, minus the present value, and they factored out the P, and they divided by P. So this is what the difference would be if you actually did compound interest or simple interest to compute the rate. So R sub B essentially is a simple interest rate needed to produce the same amount of interest in 1 year as the nominal rate, as the standard rate. What it basically says, if whether you want to do compound interest or simple interest in your formula, they're kind of equivalent. So this would be close. So like if they give you this and they say it's compounded, when you get the annual percent yield, it would be the equivalent of what would be the simple interest in this scenario. And so we're going to use the formula here. And this is basically a real nice problem. It just says find the APY, find essentially the annual percent yield. So I know I'm off the screen here, but I don't really have much space. So let me write out the formula. Okay. So if it's 4%, the interest rate is 4%, which means 0.04 in the world of decimal. The M is how many times it's compounded per year, so M is 4. So in this situation, the annual percent yield would very simply be 1 plus 0.04 divided by 4 raised to the 4 minus 1. So this just, again, formula. Parentheses 1 plus 0.04 divided by 4, close the parentheses. And you need your exponential button, raised to the 4th power, and then all that minus 1. And so this is approximate. I'm going to go 4 decimals here because we're going to put this back into a percent. So 0.0406. Now, this is not done here because this is decimal. So we want 2 places back to the right. So 4.06%. Or some people would say 4.1%. Doesn't really matter. This would be the equivalent in simple interest as opposed to compound interest. Notice how very close it is. It's usually supposed to be really close. So if you got something that's not the same as the R value or really far, then something's probably wrong. And then you have 5.1% interest in number 4, which becomes 0.051. Your M is monthly, so M is 12. So the average, your APY, your annual percent yield, would be 1 plus 0.051 divided by 12 raised to the m power 12 minus 1. So the annual percent yield would approximately be, say, parentheses 1 plus 0.051 divided by 12, close the parentheses, raised to, not parentheses, 12 minus 1. I'm sorry. I don't know you can see that. It's hard to kind of get the glare to fix to work. So 0.0522, which is pretty good. We're in the right track. So that really is about 5.22%. Or maybe in the lab or in the book, it might have 5.2% or. So that's how you do it. That's 5.2.